I am Anna Gooch, CSO of SymbioCellTech, or SCT as we call it for short. We at SCT originally set out to develop a cellular therapy for type 1 diabetes that ideally would provide an endogenous supply of insulin that is delivered physiologically, overcome the autoimmune component that is the hallmark of type 1 diabetes, and not require toxic anti-rejection drugs or encapsulation devices. Additionally, this therapy would address the issues of donor scarcity. To do this, we harnessed the powerful immune modulatory properties of mesenchymal stromal cells in order to shield islet cells from immune attack and combined MSCs in a 1-to-1 ratio with culture expanded islet cells to create 3D organoids, which we term Neo-Islets. This therapy is translatable. We've tested NIs created from mouse, dog, and human cells and found that all function similarly. Neo-islets are manufactured in a simple process as follows. First, donor islet cells and MSCs are culture expanded separately and banked. Next, when a dose is needed, some of each cell bank is thawed and co-cultured under non-adherent conditions overnight, which results in the very efficient formation of neo-islets of approximately islet size. Due to the culture expansion of islet cells in our process, approximately 270 therapeutic doses can be produced from one pancreas donor. A dose of neo-islets is then delivered in a minimally invasive process, and if safety requires it, the NIs can be retrieved. Administration is done in a simple outpatient procedure. The following images are from our ongoing FDA-guided study in pet dogs. The dog is sedated, and then under ultrasound guidance, a dose of NIs is infused over a period of a minute or so. 15 minutes later, the treated dog is ready to go home. We envision a similar process for humans, where using local anesthesia and ultrasound guidance, neo-islets would be infused IP. They would then home to the omentum where they would engraft. The omentum then becomes the new endocrine pancreas, and neo-islets deliver insulin and other islet hormones to correct the diabetic state. In our dog study, we treated spontaneously diabetic pet dogs with NIs from an unrelated donor and then followed them for a 3-year period. The endpoints for efficacy were glycemic control as assessed by serum glucose and HbA1c, and a significant reduction in the need for insulin. And as you can see, serum glucose dropped approximately 99 mg per dl and into normal range over the 3-year period. Similarly, HbA1c dropped an average of 4% and into normal range. For those dogs who have completed the 3-year study, insulin needs dropped an average of 0.85 and up to 1.2 units per kilogram body weight per day. This is significant because the average human type 1 diabetic patient requires 0.5 to 1 unit of insulin per kilogram body weight per day, indicating that neo-islets can durably produce enough insulin to meet the needs of the average human type 1 diabetic patient. Our safety endpoints were immune response to the administered cells, changes in chemistries and cell counts that would indicate toxicity, and tracking of AEs and SAEs. No dog had an immune response to either the MSCs or the islet cells that make up the neo-islets, and it is important to see here that all the dogs had pre-existing autoantibodies at baseline to islet cells, indicating that, like humans, these dogs have autoimmune type 1 diabetes. The significantly lower antibody response to islet cells at the end of the 3-year period is likely due to the powerful immune modulatory properties of MSCs. There were no significant changes in cell counts or blood chemistries other than glucose at the end of study, and no AEs or SAEs were attributed to the neo-islets. We have held a pre-IND meeting with the FDA and have received approval on the design and conduct of a final IND-enabling study. While this study is not yet funded, it is fully organized and tech transfer has taken place. With adequate funding, we expect the study to take 10 to 12 months to complete and another few months for a full IND filing, after which we would begin a phase 1/2 clinical trial in Q2 or 3 of 2025. With good results at the end of a 6-month inflection point, a phase 3 trial could begin. We estimate needing approximately $4 million to complete our study and to file the IND, and a $20 to $30 million Series A round to conduct the phase 1/2 clinical trial. Thank you for your attention.